So welcome back to this presentation. In our previous presentation, right, when we have discussed about the embedded software, or sorry, embedded platforms, right, we have discussed about some of the commonly used, embedded hardwares, right, or the embedded computers, what we generally call them as. So maybe we started from our Arduino boards, followed by the Intel Edison Galileo, very important, or what finds a lot of practical use nowadays in your IoT scenario, that is your Raspberry Pi, we call it as RPI, right? So maybe your Texas Instruments Beagle Bone and all, right? So whenever we discussed about these things, we have seen some of the important features or the salient features of these boards, and how these boards are considered as computers, right? So when we speak about the computers, we have something different in our mind, right? A credit card sized board, right? How it can be a computer, right? What features a computer has got, right? And why do you want to make it so customized here, right? All those things come to our mind, and that is basically to run certain applications with whatever the accessory points, or the whatever the accessories your computer has. Maybe your Ethernet connectivity, or maybe your Wi-Fi connectivity, GSM modules, right? Wi-Fi modules, the different ports and other things, right? So these things will make even a small credit card sized board, which we call it as embedded computer, right? So this gives the feature of a traditional computer or a conventional computer, right? And based on what are the additional things you have, the different variants you are going to have there, and accordingly we have seen the different variants among the Raspberry Pi, or even in your Arduino, or even in your Intel Galileo or Edison, or even BeagleBone. So they are, and in that cases we have even seen some of the architectural features which very much resembles with what you have seen in your microcontroller. So you have already studied microcontrollers, and the basic things what you have seen microcontrollers hold good here also. But apart from that, what all required for you to establish the connection from a physical layer, this, if you call it as physical layer, please recall your OSI reference module, right, till your application layer, may it be the data link, or the network, or the transport layer, or session, presentation, application. Sometimes they may be combined, sometimes they may be distinct, whatever it is, right? So right from your physical layer to application layer, generally in our cases we have considered only three, if you remember correctly: the physical layer, network layer, and the application layer. So whenever you want to connect between the entities, all these features are required, and once you are able to make your system to be connected to internet, then you will be able to do everything what you want to do. Because nowadays, earlier internet facilities were different. Now after your cloud computing, or the cloud paradigm has come into picture, right? So you will be able to do a lot of things without having much of the physical infrastructure with you, as long as the data handling is concerned, right? So those are referred to as the embedded computers, right? So now whenever you want to implement one IoT application, however small it is or however complex it is, so these embedded computers are mandatory or must, right? So now when you have these embedded computers, now let us look at one more diagram here. This is my embedded computers, wherein here you have got one entity where the different analog quantities being measured, right? So here you have something, right? So wherein you have your cloud or the different services what you can take it from the cloud, right? So they are present. So the establishment of the connection between these two, right? So that is takes with the help of these embedded computers that I have already told you, right? So now when I say I have things always connected to the internet, how exactly you establish the connection between the physical link or the physical layer what you have here, and this is your physical layer, and this is your internet, and I include the cloud as a part of the internet. But once you have the connectivity through the internet, then only you will be established to have the connectivity from your cloud, right? So now later I will give you some of the examples when we look at some of the case studies which could be implemented using your internet, right? So then I will certainly give you some example. Now before we go into the discussion on the case studies, let us try to see how these things could be connected to internet, that is your embedded computer, right? How exactly it can be connected to the internet, what are the different protocols that you will be using here, so that the communication between the different entities are going to be established. So in detail we have discussed about the different protocols earlier. So if you remember properly, long back we had started from the different communication technologies after having seen the very fundamental aspects of your physical layer. So in the communication technologies we have seen about your near field communication technologies, your RFIDs, Zigbees, right, wireless LAN, Bluetooth. Then we have seen some of the wired communication technologies also, right, like your pen drive, how you will connect, right? So or even the wired LAN also, right? So using the network interfacing cards and all, right? So you just recall the different protocols that were considered to establish the connection there. So after that we have seen some of the protocols related to the web connectivity, if you remember correctly, right? So again in the web connectivity, first we have discussed about some of the general aspects related to the web connectivity. Later, in particular to the internet connectivity, we have seen some of the protocols like your internet protocol version 4 or version 6, then a TCP IP, right? So the different type of the communication protocols there in the internet that we have seen. So by combining all those things, so after that we have seen some of the data handling or the data validation or the data acquisition procedures and all, wherein we have come across the big data analytics or the cloud and all. Again we have come back to the physical layer where we are using the different kind of sensors there, right? So now after having seen the sensors and all, then we have gone into the embedded computers, some of the examples we have seen. Now it is the time for us to see all of these things, right, which are combined in a entity, in a single entity, of course with the different entities coming inside the total entity what we are considering as a whole. That's what we call it as things connected to internet. So we have the things. Now let me show you the diagram here. So probably after having seen this diagram you would come across what exactly we mean by things always connected to the internet. So now if you look at this diagram, whatever distinctly we have seen earlier, so all those things now come under a single window, which gives you a picturistic view of how an IoT scenario can be perceived, right? So now here maybe to some extent we have seen this kind of diagrams earlier also, right? So but as a whole, how your Internet of Things look like, so that can be seen from the help of this particular diagram. Okay, so now here you can see things, sensors, actuators. So when I say device here, I have already told you what exactly we mean by the things, sensors and actuators. Long back we have discussed, right? So when I say device, so this device is nothing but your embedded computer. Could it be Arduino basically? Could it be Raspberry Pi? Could it be Beaglebone or Edison or Galileo? Whatever it is, right? So now, and when you have a system, it is not necessary that you will have only one embedded computer. It could be a cluster of embedded computers depending upon what kind of applications you are using. And to begin with, we will always consider, you know, a single sensor, a single computer, then a single gateway to connect it to the internet, then a single cloud service provider, and maybe a single application. So let me give you a small example here. Now so I have got a fan, right? So maybe in the very beginning I have given you this particular example. So now I have got clusters of fans, or let me say that I have got a single fan here, okay? So which is going to be controlled by virtue of your IoT. So basically I need to have some sensors here, right? So these sensors are here basically deployed to read the ambient temperature. So now you have some ray. As long as the temperature is below this value, you don't turn on the fan. Once it goes above this value, you turn on the fan, right? So now this information, right? So somewhere in your you would store it, you would exit from the cloud, you have the temperature measurement here, you connect it to cloud and you get it back, and based on the information received from the cloud, you make the arrangements to, you know, turn on your actuator or turn off your actuator to either turn on the fan or turn off the fan, right? So this is one simple example. The same thing holds good for even your street light applications. I have already told you earlier in detail how it is possible for you to control a street light, right? Again, bring everything into picture, your sensor or sensors, because there will not be one street light to be controlled, there will be several street lights, there will be a cluster of street lights area wise, right? So they may be independently controlled. For that you will have to have your own programming and all, and your cloud is your resource there, right? By looking into the data which is available in the cloud, right? So you make your computers or the embedded computers to take the action, and accordingly at the physical layer you will be able to either turn on or turn off the corresponding lamps in the street light scenario. So now when I tell about these things, right, what are the different things that could be involved in the overall procedure, that is called, or that is explained by the help of this particular diagram, right? So now here we have got the sensors here, as I've already told you, the things, right? The sensors, actuators. In the very beginning we have seen what exactly we mean by things, right? Then using this particular mechanisms, so these things get connected to the device. We have already seen these things in our previous discussions, right? So it could be Bluetooth or Zigbee, wireless or wired technologies, near field communication, right? Wi-Fi, whatnot. We have already seen about the different communication technologies which have got their own way of communicating with the devices with their own protocols. So that takes care of your physical layer, and it is also referred to as adaptation layer, because whatever the raw data that you are going to measure, so they are going to be converted into a useful information, or the informations put in the right format or the right form, right? So then you can see here, after your devices, so how do the devices communicate to the internet? This is again very important. So when I speak about the devices, you know that there are the provisions for you to have the Ethernet connectivity, there are the provisions for you to have the Bluetooth connectivity, there are the provisions for you to have the Wi-Fi connectivity, and accordingly making use of any one of these or multiple depending upon the requirement, right? So your devices will be able to communicate to the internet, and you can either use the Ethernet shield, or you can use the Wi-Fi module, or you can use the GSM module need based, right, by virtue of the gate. Very, very important. I have already told you earlier also what exactly we mean by the gateways. Gateways will make the connectivity between one entity to another entity, provided there are proper connectivity established, there is a compatibility between the two entities, right? And you have the establishment of the connection by virtue of your what we call it as media control. MAC also we have seen, media access control. This also we have discussed to some extent, right? So each network or each node which is connected in the network will be having a media access control address, right? So basically a device node, right, receives the data stacks using its media access control addresses. Generally, what do you mean by media in this case is the physical media, right? Or it could be optical fiber or the wires, right, which a device or node has got the access to the internet, right? So basically it is the physical media, and all of you know what exactly we mean by the node here, right? Again, it is an IoT device, or it could be sensor, or it could be actuator, or it could be controller, or even the computer. About this we have already discussed in a detailed way earlier, and every media access control address has got a 48-bit, right? And by virtue of this, it is possible for your devices to connect to the internet, right? So all of you may be having your internet connectivity at your home, or nowadays we have the wireless connectivity, which is more preferred, right? Whether it is the wireless connectivity or the wired connectivity, whenever you want to have the access to the internet from your the devices, so any one of these things whatever we have seen, right, so they are must. So by virtue of that, you will be able to connect to the internet, right? So now once you connect it to the internet, right, once you connect it to the internet, so how the different protocols can be used there. So we have already seen this also, IPv6 or 32-bit IP address, or even your IPv4, right? So all these things are used for you to have the connectivity to the web server or your cloud. So some examples I will give you. So whenever I speak about the cloud, right, so we have one important, there are so many cloud service providers, but we have something called as ThingSpeak. ThingSpeak. So you can just Google it. The ThingSpeak gives you free access to the cloud, of course with the limited capability. It cannot give the complete whatever you wish to have, that much cannot be supplied, right? And maybe in some of our experiments, which probably we will be conducting in our next semester, where your sensor and control system lab is there, so there you should be able to practically demonstrate some of the IoT experiment if everything goes well, right? So using your basic sensors, maybe a temperature sensors, and using your cloud service somewhere here. I am talking about the sensor here, I am using my cloud service here, how I should be able to control devices here. That's what will be one basic explanation of using the IoT to the most primitive extent or the most basic extent, right? Once you are able to do that, then definitely you should be able to use different enhanced kind of services, and you can have your own applications, of course, for which one of the programming languages, preferably Python, is very much essential. I have been telling to you in the since beginning, right? You should have some idea about the Python. Python is a very easy language for you to understand, so long as you have got the idea about the C programming, and even your embedded C 8051C also you have studied to certain extent, though you have not implemented any real-time projects on that because of this prevailing situation. But definitely I would give you, or I would share you some at least 4 links, the YouTube links, wherein you should get some basic idea or a concrete idea about how to develop your own applications as long as the IoT is concerned. Maybe by making use of your Python and Raspberry Pi, right? So after you watch those 4 videos, so you will get some idea. It is in addition to whatever we have in our curriculum, right? Apart from that, whatever the extra you need to have, because whenever I speak about the IoT, right? So we are basically in this course discussing about the fundamental aspect of this. Fundamental, again, I don't repeat whatever I have been telling there, right? But its real essence you will be able to understand only when you develop your applications, right? So for you to be conversant with developing your own applications, you need to have some idea about the Python, the basic programming language here, or and you should be able to use one of the embedded computers which we have discussed so far. Could it be Arduino? Some of you are very comfortable with the Arduino, right? But Arduino has got the limited features, and according to me, Raspberry Pi is the preferred one, which I have been telling earlier also. And by making use of the Python programming, and by making use of some of the freely available cloud services like ThinkSpeak, right? And by making use of the Python programming and Raspberry Pi, so you should be able to develop your own application, which whoever is interested, you can explore these things and you can definitely have your own applications developed. That is what one additional thing I wanted to tell you here, right? So now by making use of these kind of things, so you should be able to have your own the cloud picture there, right? So you can subscribe the cloud services like ThinkSpeak and all, and probably you will be able to communicate from your cloud till your basic sensors or the basic things what you call here by means of this kind of system, right? So you can have the Arduino as the basic aspect here, right? If you consider Arduino, right, you can have the Arduino USB connected to the internet. So how exactly the Arduino IDE supports USB connection, right? So USB ports, how they are to be configured in the Arduino, you will get from all the information from your Arduino IDE, integrated development environment. So that's what is the significance of your internet or integrated development environment. Then how you will be able to connect your Arduino to the internet. I am talking about the connection of the Arduino USB to the internet, or the connection of the Arduino directly to the internet, because your Arduino IDE, right, it supports the Ethernet protocol library, something we call it as Ethernet protocol library, right. So by virtue of which, basically this library means there will be a set of the codes which are meant for the specific purposes, right. So whatever the Ethernet LAN you have in your Arduino, right, it will directly connect the network router or through Wi-Fi adapter to the wireless modem to the internet. So by means of that, it is possible for you to have the connectivity of the Arduino directly to the internet. And now when I speak about that here, so now suppose if this is your Arduino, right, so either through the Ethernet you can have the connectivity to the internet, or by use of the Wi-Fi module you can have the connectivity to the internet. So this particular task is facilitated by Arduino integrated development environment. Some of you, those who have already worked with this, you must be knowing, and you will be able to connect your Arduino to the Wi-Fi, right, so using the suitable Wi-Fi protocols also, right. So now if this is the case, the same thing holds good for the other devices also. Could it be your Raspberry Pi, or could it be your BeagleBone, or Galileo, or Edison, whatever it is, right. So like that, you should be able to have your own application. The one example I have already given you earlier, a fan, right. So having the temperature sensed by your either a basic sensor, or by means of the weather software. There are so many weather monitoring softwares, you may be knowing that, right. So these weather monitoring softwares can be directly accessed from your internet, and in your place what exactly is the temperature right now, that also can be accessed. So this is how you access the service from the service provider using the cloud, or using your basic sensors. You can put the data into your clouds, maybe which are not changing, right. So you can use some of the LDRs, right, so the light detecting resistors, or sometimes you can customize the turning on and turning off the light, say that is after 6 o'clock till 6 o'clock in the morning. So that is based on the system clock, right. Whenever the system identifies that it is 6 o'clock in the evening, it will see to it that the lights are directly turned on. For that, you will be using the system clock, or even a part of your the cloud service. So how to achieve these things, or how to materialize these things, right. So that requires some kind of the knowledge of the different protocols, right, the different applications, or the different types of the services which your cloud service providers give you, right. In that context, you must have the idea about some programming language, as I've been telling, and even the embedded computer with you, right. So without the embedded computer, it is not possible for you to materialize these applications. Okay, so this is one simple presentation which I wanted to give you, which tells you about how the things where you have the sensors, actuators, or the devices, or the circuit boards like your device 1, device 2, or device 3, whatever we have seen here, right, they get connected to the internet as well as the cloud or the web server, right, for the applications and services, right. So now when I tell about this, this is to be practically implemented. So in order to implement these things practically, you need the different protocols to be understood, different or one important programming language to be understood, and one module, right. So that is Raspberry Pi or the Arduino, whatever you have, that is to be with you. And apart from that, you must subscribe to one of the cloud services, if at all you want to have something accessed from the cloud, right? So with this I will stop this presentation now. I am not going into the further details, and in our next presentation we will see something about the devices, gateways, and the internet services for the software development. So we have to have our own software development here. We have the physical layer, we have the data link layer, network layer, application layer, and in each layer the very development of the software, it is different, and it is dependent on the different kind of services. So therefore, right, for OT or MOM, that is the machine to machine communication, right? So how we will be able to develop the different softwares for the applications and services for your IoT or machine to machine communication, that we shall see in our next presentation. If you have any doubt here, please ask.